Chapter 7 exam, question 1, part A. Part A of question 1 asks, the work energy theorem states that a force acting on a particle as it moves over a blank changes the blank energy of the particle if the force has a component parallel to the motion. So we're using the work energy theorem, which is kinetic final equals kinetic initial plus W net, work net. And then for that, is the energy formula, work energy formula, has to do with kinetic energy. So the only answer with kinetic energy is distance slash kinetic. So the work energy theorem states that a force acting on a particle as it moves over a distance changes the kinetic energy of the particle. The force has a component parallel to the motion. The force of the component acting is in the direction of the motion of where the thing is going. Part B asks, to calculate the change in kinetic energy, you must know the force as a function of blank. The work done by the force causes the kinetic energy to change. Acceleration, no. Work, no. Position of potential energy. It's not potential energy because we changed in kinetic energy. You must know the force as a function of position due to moves over distance. Position and distance are closely related to one another. Part C. To illustrate the work energy concept, consider the case of a stone falling from x initial to xf final under the influence of gravity. Using the work energy concept, we say that work is done by the gravitational blank, resulting in an increase of the blank energy of the stone. Gravitational, from the answers we have either force kinetic, potential energy slash potential, force potential, potential energy slash kinetic. Since the gravitational, it's going to be gravitational force due to gravity. So the only ones are available are either kinetic or potential. And work energy, gravitational resulting in an increase of the energy of the stone. If it's falling, then it will be increase in kinetic energy. Part D and E will be using the potential energy theorem concept. Part D asks, rather than ascribing the increased kinetic energy of the stone to the work of gravity, we now, when using potential energy, rather than work energy, say that the increased kinetic energy comes from the blank of the blank energy. Comes from the blank of the blank energy. Which would be the change from change, because you're changing. Changing due to the increase in kinetic energy comes from the change of potential energy. Whenever an increase in kinetic, it means you change it from potential energy to kinetic. And last but not least, part E. This process happens in such a way that total mechanical energy equal to the blank of the kinetic and potential energy is blank. This part happens in such a way that the total mechanical equal to the sum of the conserved. Zero of the kinetic and potential energy is 0, no, not conserved, is be conserved. Okay, part A is distance kinetic due to distance-wise for work and kinetic energy, because we're using the the kinetic work energy theorem, which has to do with kinetic. And the force acting parallel to the motion of the object increases kinetic energy of the object. Part B is position, because you're changing the distance wise, and position, work done causes it. And then part C is force and kinetic due to the work done by gravitational force decreases the potential energy when the gravitation is acting on object. It decreases the potential energy and increases the kinetic energy of the object. Part D, you're changing from potential energy, you're increasing kinetic, so you're changing it from potential to kinetic. Part E is this process happens in such a way that total mechanical energy equal to the sum of the kinetic and potential energy is conserved.